So what's the test statistic we use to determine whether eye color and gender are independent or not independent? Well, what we have to do is, under the assumption of independence, compute the expected number of people that would fall into each of these cells: female blue eyes, female brown eyes, through male hazel eyes. That's called EIJ, the expected number in the cell under independence. And what you do to calculate that is take the total number of people, which we've got. We actually have the total number of people here. We can just add these up here. 2,035 people. So you want to ask yourself, what fraction of the people would you expect to be female with blue eyes if there was independence between eye color and gender? Well, you take the total number of people times the fraction that basically would be female, that's P7 divided by the total, and then multiply by the fraction that basically had blue eyes. Because if you had independence, you remember back to Module 2, you can get the probabilities of independent events by multiplying their respective probabilities. And so under independence, you could find the fraction of basically people who are female with blue eyes by taking the fraction of females times the fraction with blue eyes times the total. Now, if they weren't independent, this wouldn't work. So we'd expect when we get these expected values, they'd be pretty close to the observed values. So how do we statistically measure that? We take the observed value minus the expected value in each cell squared, divided to normalize by the expected value. Okay? And then we add those all up, and that gets our test statistic. And that'll be compared to basically a critical value from the chi-squared table based on degrees of freedom. There's a function chi-squared dot inverse, and the 95th percentile would be the critical value. So I put some of those here. If you had 1 degree of freedom and you add up all these complicated things and it's greater than 3.84, you reject the null. 2 degrees of freedom and it's greater than 5.99, you reject the null. 3 degrees of freedom and it's greater than or equal to 7.81, you reject the null. 4 degrees of freedom greater than or equal to 9.48, you reject the null. And in our example, the number of rows is 2 and the number of columns is 4. So basically with rows equal 2 and columns equal 4, we've got 2 minus 1 times 4 minus 1. We've got 3 degrees of freedom, or DF for short. So let's get those expected values in each cell, and then the test statistic would be the observed minus expected squared divided by the expected in each cell. We add those together, we can get a total chi-squared statistic, and then in the next video we can conclude basically should we accept the null hypothesis or reject the null hypothesis, and there'll be a couple of ways we can approach that final step. But we've got to get these expected values, okay, in each cell. So that's the key step. So again, how do we get the expected values? We take the total number of people here. We want a formula we can copy across. The total number there times the fraction of women. Okay, so P7, okay, tells us how many women. Now I'm going to need to dollar sign the P there because I want to copy that across and not have the P change. And then I divide that by the total. I've named that cell total. We discussed that in Module 1, how you can do that. Okay, so that's the fraction of women times the total. And then I multiply times the fraction that basically have, in this case, blue eyes. Okay, so blue eyes would be right there. Now I'm going to need to dollar sign the 9, because if you think about this, when I copy this across and down, what do I want to change? So basically, I don't want the 9 to change because basically I've got my totals there. Okay, but I do want the L to change. Okay, because I want to get different color eyes as I go across. So that's L9 divided by the total. Okay, so to recap what we have there, I mean, if there's independence, how many women would you expect with blue eyes? You take the total times the fraction of women that you have in your data set times the fraction of people who have blue eyes. And again, L9 has the blue eye people. And then basically you'd copy that across. So I think, let's see what we get there. We get 396.56, that's right. So when I copy that across, Okay, get 349 there. Now I can drag this down. And then basically these totals should match the observed totals if we've done this right. So we get 1107, that's good. And I copy that down, I get 928. So again, these are the expected number of, for instance, females with blue eyes, males with brown eyes, you'd expect if gender did not affect eye color because we multiplied these fractions here. Now, what is the test statistic in each cell? It's going to be the observed value, that's going to be up here, minus the expected value, which we just got, and we're going to square that, and then it says to divide by the expected, sort of to normalize that. Now the expected is right there, and that should copy across fine. So I get a 1.78 there, drag that across and down, and we'll get a total for the chi-square statistic, and then we'll analyze it in the next video. So we got a chi-square statistic of 16.59, and in the next video we'll show you whether or not you should, based on that test statistic, accept or reject the hypothesis that eye color and gender are independent.